It began with a single stubborn idea, an idea hammered out in the dim glow of a kerosene lamp, sketched on scraps of paper spread across a kitchen table, and refined in the relentless rhythm of a lathe and milling machine. John C. Garand's early years in Worcester were a study in contrasts, the steady, repetitive noise of factory floors by day and the deliberate, almost musical clatter of metal being shaped by hand at night. He had come to America carrying more than tools, he carried the weight of an immigrant's hunger and a craftsman's obsession. That hunger was fed by memory, stories of slaughter in the mud of Flanders, letters from soldiers who had returned home with their bodies intact but their trust in existing technology broken. The bolt-action rifles that dominated the Great War were simple, reliable, and lethal in their own way, but they demanded time-consuming manual operation between shots. Garand saw in those pauses, the flick of a bolt, the grunt of a man resetting his aim, not only lost seconds but lost lives. From the beginning his aim wasn't to design a novelty for its own sake, it was to design a tool that would reduce the human cost of war, a machine that matched the rhythm and chaos of combat with speed, simplicity, and rugged dependability. The early prototypes were crude and frequently failed. Springs snapped, cartridges jammed, tolerances that seemed insignificant on a warm bench in Worcester became fatal flaws when tested in cold, muddy trenches or in the grit of a desert wind. But each failure taught something. Every broken spring mapped a place where the design begged for robustness, every jam revealed the need for foolproof feeding and extraction. Garand read widely, not only patents and technical manuals but wartime accounts of soldiers who improvised in the field, seeking patterns that the data might miss. He apprenticed himself to problems of metallurgy, heat treatment, and ergonomics. He learned the temperament of steel the way a violinist learns the temperament of wood, by touch, by listening, and by unending tinkering. Nights were spent not only sketching but calculating. He would labor over tables of dimensions, comparing recoil impulses, bolt travel distances, and the energetics of new cartridge designs. Friends joked that he slept with a micrometer. In a real sense he did. His dreams were populated by spring rates and feed ramps, by the satisfaction of a clean, smooth cycling action. Yet for all the technical obsession, Garand never lost sight of the human element. He designed for the hands that would operate the rifle, the calluses on the palms, the way fingers slipped when numb with cold, the need for a trigger that was consistent and forgiving. He measured the balance between precision and forgivability because he knew a rifle is ultimately judged not by the elegance of its mechanism but by the man who trusts it while bullets fly. The local community watched with a mixture of curiosity and skepticism as the French-Canadian machinist spent evenings in his small shop. Some saw nothing more than tinkering, others sensed something more, whispering about inventions that could change warfare forever. But innovation rarely arrives announced by trumpets. It arrives through the dogged repetition of small improvements and the stubborn refusal to accept the status quo. Garand's first successes were private victories, a prototype that ejected empty cases with remarkable consistency, a feed system that tolerated a soldier's hurried reload, and each success earned him not laurels but more problems to solve. With every refinement the scope of the challenge broadened. A lighter action traded durability for weight, a stiffer spring reduced stoppages but increased the force a soldier needed to cycle the mechanism manually if required. It was a dance between competing needs, reliability in the worst conditions, speed when the moment demanded, and simplicity in the heat of combat when a soldier had no time to love the machine that kept him alive. Beyond the bench, Garand faced the political and institutional obstinacy that greets most disruptive ideas. The U.S. Army bureaucracy at the time had been forged in an era that prized standardization and incremental improvement over radical redesigns. Military procurement operated on a rhythm of conservative caution, trial, test, and the slow accumulation of evidence before a single cent of taxpayer money changed hands. An immigrant with blueprints and determination is romantic in narrative but unproven in the ledger. Yet Garand grasped this reality and learned to navigate it. He kept meticulous notebooks, documented test results with the precision of a scientist, and cultivated the one ally every inventor needs inside a resistant institution, credible evidence. He demonstrated not just the rifle's mechanics but its potential to change doctrine, how an individual soldier with a semi-automatic rifle could alter the tempo of fire, influence squad tactics, and reduce exposure time while reloading. He argued not with flair but with charts and live demonstrations, sometimes enlisting local soldiers to fire his prototypes and then listening, with a humility that belied his quiet determination, to what those soldiers said. Their critiques became his curriculum. The path from lit workshop to army testing range was neither straight nor swift. Garand traveled to Washington with models wrapped in cloth. He stood patiently in corridors where secretaries and clerks sifted through the steady stream of innovations that sought military favor. He paid for travel with savings and the occasional loan from a sympathetic friend. His pitches were polite, relentless, and always returning to the same point: a soldier should not have to sacrifice accuracy for rate of fire. If speed can be married with reliability, then the cost, in training, in logistics, in human life, could be dramatically reduced. Some officers listened, some frowned, and many remembered him as yet another tinkerer, but among them were a curious few who asked for tests. Test after test then returned the same stubborn truth: a well-executed semi-automatic could offer the soldier fire superiority without the fragility that had doomed earlier automatic experiments. Garand's design still had rough edges, but those edges could be ground away with the right combination of funding, engineering support, and manufacturing discipline. That realization opened doors. Contracts were rare and precious, yet once an institution as large as the U.S. Army showed interest, the momentum shifted. Still, the transformation from prototype to adopted service rifle meant reconciling the small, careful world of a machinist's bench with the vast, industrial calculus of wartime procurement, quantities, interchangeability, supply chains, and the politics of arsenals with long-standing suppliers. It was a world where every small design choice took on macroeconomic consequences. Garand faced it not by surrendering his standards but by insisting they scale, convincing others that a design that worked in one hand could be manufactured reliably by the thousands. That stubbornness, a refusal to accept compromise on core requirements, would later define both the rifle and the man who created it. The next phase of the story is as much about stubborn institutions and shifting doctrine as it is about metal and springs. As World War II approached, the United States Army found itself forced to rethink not only strategies and theaters but the equipment that would equip its soldiers on multiple fronts: the hedgerows of Normandy, the stone-lined streets of Europe, the arid expanses of North Africa, and the jungles of the Pacific. The rifle question became a central problem because warfare had evolved. The sustained, mobile engagements and intense close-quarters fighting of the early 20th century made the bolt-action rifle's limitations painfully apparent. In this crucible, Garand's semi-automatic concept gained traction not because of a single brilliant sale but because of relentless demonstration and the slow accumulation of allies who made the case that the tempo of modern battle demanded a rifle that could deliver rapid, accurate semi-automatic fire without the logistical and mechanical nightmares of early fully automatic attempts. The Garand, as the battlefield would come to know it, was not merely a product of one man's genius but a node in a network of engineers, ordnance officers, machinists, and rank-and-file soldiers who iterated on its faults and celebrated its virtues. Field trials revealed both strengths and challenges. In the hands of an experienced shooter, the rifle's balance and trigger allowed for controlled, accurate rapid fire. Its 8-round and block clip was easy to load in the heat of battle and offered more sustained fire than a bolt-action without the weight and recoil. Intensity of a light machine gun. Yet the rifles and block system required discipline in reloading and could present problems if dirt or deformity interrupted the clip's seating. Garand and his collaborators took these lessons to heart, redesigning feed ramps, improving extractor geometry, and rethinking the materials used in the receiver and bolt to resist erosion. The process of refinement was iterative and sometimes contentious. Some critics suggested moving to detachable magazines, which offered modularity and quicker top-offs. Garand resisted, not out of stubbornness but because the en-bloc system simplified training and reduced the number of moving parts exposed to the elements. He believed that the absolute best solution in the chaos of combat was the simplest robust solution: fewer parts meant fewer failures. This philosophy echoed his origins as a machinist who had little patience for complexity that didn't measurably improve reliability. As adoption grew more plausible, the rifle's story intertwined with industrial politics. Factories that had produced bolt-action rifles for decades saw orders shifting, new suppliers sprung up, machining tolerances had to be standardized across plants that produced parts in different states. Garand watched as the manufacturing process matured, as jigs, fixtures, and quality control standards were developed to produce his rifle at scale without losing the fidelity of the original design. This was industrial engineering at its most human, thousands of workers shaping metal into tools that would alter the fates of men thousands of miles away. The rifle also forced a doctrinal reckoning. Commanders had to adjust squad tactics and logistics to the reality of semi-automatic fire. Ammunition consumption patterns changed, training curricula were updated to teach soldiers how to manage rapid fire without sacrificing accuracy or expending their rounds in wild bursts. The psychological effect was profound. Soldiers who carried the semi-automatic felt an increased confidence in their ability to outpace a bolt-action enemy, to lay down suppressive fire while maneuvering, and to react quickly without losing the precision that the battlefield still demanded. Stories from the front describe how a squad's ability to push forward under the covering raid of a soldier with a Garand transformed otherwise stalled assaults into advances. Yet the rifle was not a panacea. Its success hinged on logistics, training, and the adaptability of soldiers and commanders. When those elements were lacking, the rifle's advantages diminished. Garand continued to travel, to observe training camps, to listen to NCOs and privates alike. He insisted on modifications that made the rifle easier to maintain under field conditions, easier to disassemble, simpler to clean, and less sensitive to the waxing and waning of supply chains. In those interactions he learned lessons about the practicalities of war that no blueprint could teach, the importance of spare parts stocked at forward depots, the need to design for soldiers who were tired, hungry, and sometimes poorly trained, and the moral obligation to produce an instrument that, while undeniably a weapon, reduced needless suffering by offering reliability and predictability in the fog of combat. By the time the rifle was being manufactured at scale, it had become an actor on the stage of history. It arrived in the hands of soldiers whose lives would be shaped by its presence. Critics would later argue about tactical doctrines and the relative merits of automatic weapons versus semi-automatic rifles, but the lived reality for those holding the Garand was the immediate and profound increase in individual firepower and the psychological comfort of trusting one's tool to function when everything else around you was chaos. The rifle's impact radiated outward, it changed infantry training, it altered how small units organized fire and maneuver, and it forced militaries worldwide to reconsider the balance between rate of fire and reliability. In the human story, in letters home, in diaries, in the halting reports of rookies who suddenly found their voice when given a rifle that could keep up with their courage, Garand's invention helped rewrite what was possible on the battlefield. Innovation is never divorced from controversy, and the Garand's ascent was no exception. Debate raged in military journals, in the halls of ordnance, and in the quiet rooms where generals stared at maps and supply charts. Some argued that the rifle was merely an expensive incremental improvement, that the enormous industrial investment required to replace existing weapons systems could not be justified in peacetime budgets or even in the early years of a conflict that might be won by other means. Others raised concerns about maintenance under war conditions. Would armory depots be able to supply a new set of spare parts? Could soldiers in remote theaters be trained quickly enough to use the new system without increasing misfire rates? Garand confronted these objections not by dismissing them but by anticipating them, attenuating them, and presenting solutions that were practical and tested. Cost-benefit analyses were performed, and the outcomes were not purely technical, they rested on judgments about human endurance, political will, and the moral calculus of how best to equip a citizen army. Beyond procurement debates, the rifle's success forced an uncomfortable cultural shift within the military. For generations, the bolt-action rifle had been not merely a piece of kit but a cultural artifact, a symbol of disciplined volley fire, of the steady line of trained shooters. The adoption of a semi-automatic challenged that lineage and demanded a new training philosophy that emphasized individual initiative, rapid target acquisition, and maneuver. This was not an easy cultural change. Institutions resist changes that threaten long-standing identities. Yet as stories from combat filtered back, from Normandy hedgerows where American squads could supplant freezing enemy positions with sudden, sustained semi-automatic fire, or from Pacific Islands where rapid, accurate fire could mean the difference between holding a ridge and losing it, the practical advantages of the Garand became hard to deny. Garand himself became a figure of quiet controversy. Some hagiographies cast him as the solitary genius, the man who single-handedly revolutionized infantry warfare. Critics pushed back, emphasizing the collective work of ordnance engineers, manufacturing teams, and frontline soldiers who shaped the rifle through feedback and adaptation. Garand accepted neither caricature and instead flourished in the gray area. He honored the contributions of those who helped him, and he accepted refinement and critique as part of the work. His humility was an instrument of his success. By the time the rifle was in widespread service, he had cultivated a reputation not only as a gifted machinist but as a man who listened and learned from those who would use his invention. The ultimate judgment of his work would not be sealed by veteran testimonials or prize ceremonies but by the cold arithmetic of reliability in the field, mean rounds between failures, ease of repair, and the rifle's performance under extremes of climate and wear. In those tests the design proved itself. Soldiers who had known only bolt-action rifles learned how to manage an 8-shot end-block clip with efficiency, mechanics learned to maintain the guns with basic tools, manufacturing plants refined tolerances to produce guns that were functionally identical whether they left a plant in Massachusetts or one in the Midwest. The result was a weapon that became more than the sum of its parts. It became an instrument that amplified a soldier's capacity for survival and effectiveness. Garand's rifle also left a quieter legacy. It altered how societies considered the relationship between technological innovation and humane warfare. The premise that a better-made weapon could, paradoxically, reduce casualties by making individual soldiers more effective and thus able to end engagements more quickly was controversial but persuasive. In the decades that followed, debates about armament ethics would continue to be shaped by this paradox. Garand's work forced policymakers to reckon with the uncomfortable truth that improvements in technology can, at times, serve humanitarian aims by reducing prolonged exposure to danger. It was a complicated moral argument, one that refused easy slogans, but it mattered deeply to a man who had started with the simple belief that a better rifle might mean fewer deaths. In personal terms, Garand watched his name become associated with a rifle that would carry into battles around the globe. He received medals and recognition, but he retained a private pride that was practical and unshowy, a letter from a commander noting how dependable a rifle had been under fire, a report from a maintenance sergeant describing how few parts needed replacing in the cold of an Alaskan winter. Those small validations meant more to him than any parade. He knew, as inventors do, that real success is measured not by monuments but by the subtle confirmation that a tool does the work it was intended to do, day in and day out. The final paragraph of this arc must reckon with legacy, both the immediate tactical legacies and the more diffuse, cultural ones. The rifle that emerged from Garand's shop did not merely appear in history textbooks as an object, it entered the lived experience of tens of thousands of soldiers, reshaped small unit tactics, and influenced the design logic of future service rifles. Its practical effects were immediate. Increased sustained fire from individual riflemen altered the calculus of assault and defense, contributed to the successes and survivals of countless soldiers, and demanded new training regimens that emphasized maneuver under covering fire. But its deeper legacy was conceptual. The Garand helped collapse the distance between precision and volume of fire, showing that you could have both if you were willing to invest in smart design and rigorous manufacturing. In the post-war years, as armies around the world reassessed their small arms, the lessons learned from the Garand fed into new paradigms of infantry armament, detachable magazines, selective fire systems, and an emphasis on modularity were all discussions informed by the practical triumphs and the limitations observed in Garand's rifle. Designers studied where its simplicity excelled and where its fixed elements constrained adaptation. Every future design was, in a sense, a critique and extension of that original work. For Garand personally, the later years were quieter. He continued to tinker but shifted from the urgency of invention to the reflection of mentorship. He advised younger engineers, visited arsenals, and watched as manufacturing processes matured into more automated and standardized systems that would have bewildered the machinist of his early days. He understood that his rifle was part of a lineage of human attempts to solve problems that, at their roots, were human: how to protect, how to project force, and, paradoxically, how to reduce suffering through better tools. The world that the Garand rifle helped shape was not simply a more lethal world, it was one in which the human dimensions of warfare, training, logistics, doctrine, and the psychology of soldiers, were recognized as integral to the effectiveness of any weapon system. The rifle's name entered popular memory not as mere technical trivia but as shorthand for an era when industrial capacity, engineering rigor, and human courage combined to meet the urgent demands of a global conflict. Museums would later display the rifle behind glass, and historians would debate its merits in lectures and papers, but for those who carried it, the memory was immediate and kinetic: the weight against the shoulder, the clean snap of the end-block clip seating, the feeling of controlled fire that let men hold ground and protect comrades. This is perhaps the most profound measure of Garand's work, not the medals, not the patents, but the lived gratitude of soldiers who, holding a tool they could trust, found themselves better able to survive and to act. Looking back from a distance of decades, the story reads like a parable of invention itself, a mixture of stubborn curiosity, practical skill, institutional friction, and the steady, sometimes unsung work of craft that turns an idea into a machine that matters. John C. Garand did not seek to glorify war, he sought to make the soldier's tool more dependable, a humane impulse in its own paradoxical way. His work reminds us that technology is never neutral, it carries within it choices about complexity versus simplicity, mass production versus artisanal care, and above all, an ethic about how we weigh human life amid the machinery of conflict. The Garand rifle stands as a testament to the possibility that careful, conscientious engineering can reduce suffering even in the bitter context of war, and that sometimes, in a small Worcester workshop at midnight, a single person's obsession can ripple outward to change the fate of many.